Hello gentlemen, welcome back. We're going to now move into solving trigonometric equations. This is going to take a lot of practice. We're going to use a lot of different techniques here. I'm going to use some graphing. We're going to use our calculators. I want you to understand that many of these have infinite amount of solutions, and we have to be able to describe those solutions. And so it's going to take some practice. We're going to need to use some of our fundamental identities to solve. We're going to use some factoring. We're going to use a bunch of different techniques, so make sure that you're keeping up, you're paying attention to examples that are in the book, and you're pausing the video to practice with me. I mean, this is going to be really critical as we start to solve trig equations because they can get a little bit complicated. Okay, let's get started. We'll start with a pretty straightforward example. 2 sine of x is equal to 1. But this is going to it's going to show us a couple different things, even though that the solution isn't overly difficult or the problem. It's going to highlight a few things for us. Again, we want to try to isolate the trigonometric function by itself when possible. And so I'm going to bring to 1 to the other side, and then obviously I'm going to divide by 2. At this point, if I was solving an equation, what I would want to do is do the inverse of the sine, which is take the arc sine of both sides. And we know how to do that. And so I will get x is equal to arc sine of a half. And I know what arc sine of a half is. I've done that. I know my unit circle. And I know that arc sine of a half is equal to pi over 6. So I know that pi over 6 is a solution to this equation. However, there's an infinite amount of solutions here because the sine function is periodic. Okay? So I have a solution here, I have a solution here, I have a solution here, etc., etc. And so what I want to do is to describe each one of those solutions. And to do that, let's look at on the interval of 0 to 2 pi first. Okay, on 0 to 2 pi, there's 2 values such that sine of x is equal to a half. They occur in quadrant 1, which is pi over 6, and the other time it occurs is in quadrant 2, when theta is equal to 5 pi over 6. And again, you guys should know this. All right, though that's just knowing your unit circle. Now what we want to do is also look at the fact that the sine is periodic and that the period of sine is 2 pi. We need to make use of the fact that the period is 2 pi. If we do that, we're going to have general solution of pi over 6 plus 2n pi. In other words, here's pi over 6 right here. That's my first solution. If I go all the way through one complete cycle, I'm back over here. That's also a solution. And I can keep that process going. For example, here's 5 pi over 6. If I go 2 pi plus that value, I end up right there. And so in other words, another solution to this equation would be pi over 6 plus 2 pi. Okay? And 2 pi is equal to 12 pi over 6. So that's 12 pi over 6. And so another solution is 13 pi over 6. Okay? And then I can say 25 pi over 6, etc., etc. And I can do the same thing with 5 pi over 6. I can go to the right, I can go positive values that way. I can go back negative values. And so I could say that pi over 6, I could do pi over 6 minus 2 pi as well, right? Because this goes in both directions. Periodic function goes both directions. And again, so I will get pi over 6 minus 12 pi over 6, and that's negative 11 pi over 6. So that's also a solution. So there's an infinite amount of solutions here. But what did I do is I found my solutions on 0 to 2 pi, and then I used the fact that the period here was 2 pi. Okay? Let's do another example. Solve the equation. Again, now this one has sines and cosines involved in them. And when we can have sines and cosines involved and we can get rid of that and make it tangent, that would be ideal. So if I divided both sides of this equation by cosine squared, then I'm going to get tan squared. Okay, because sine squared over cosine squared is tan squared. To get rid of the squared, I have to take the square root. And this is where we need to be a little bit careful because we can't forget the minus part of this. So I have tan x is equal to plus or minus square root of 3. Okay. Well, we can do that. We can say x is equal to arctan of root 3, and x is equal to arctan of negative root 3. Again, we know how to handle those different situations. Okay, and we get pi over 3, and we get negative pi over 3. Again, this part is knowing your unit circle. But again, let's remember that the tangent function is periodic. So here's my tangent function. This purple line here is the square root of 3, and the gold one is square root of negative square root of 3. And so you can see that we have an infinite amount of solutions. This value right there, that's my pi over 3. X is equal to pi over 3. This one is equal to negative pi over 3. Because remember, for tangent, when we use arctangent, we're going to go from negative pi over 2 to pi over 2. So I'm getting the solutions that are right in this area right here. I haven't found any of these other ones. So here we have to make use of the fact that the period of tangent is pi. Make sure you guys realize it's only pi. Remember, tangent and cotangent period is pi. The others are 2 pi. So if I do that, what I'm going to find is that pi over 3 plus n pi is going to give me an infinite number of solutions. It's going to give me that point, it's going to give me that one, and backwards this way as well. And this part is going to give me these solutions down here. Okay? Oftentimes they're going to ask you to solve on a specific domain. So here I'm asking you to solve on 0 to 2 pi. I'm asking you to solve this on 0 to 2 pi. Again, we have sine squared and cosine. There's no way to look at and get a tangent out of this because I'll get a squared. I don't have a squared term here, and I have a subtraction on this side. It would be nice to get in terms of just sines or cosines, so I can use my Pythagorean identity here. Okay, this is going to make my entire equation just have cosines. When I just have cosines, it's going to be easier for me to solve. Okay, so what I would do at this point is I would expand through and try to combine terms. So I'm going to get, if I do that here, I jump through a couple different steps, but let's look at them. I did 2 minus 2 cosine squared of x is equal to 2 minus cosine of x. Obviously the 2's and the 2's are going to cancel like that. Okay, let's bring this term to the other side, and that's where I got this term right here. Okay, at this point what I would do is I can factor. Okay, let's factor out a cosine out of this. If I factor out a cosine, here's my graph. If I factor out a cosine, I have cosine x times 2 cosine x minus 1. Okay, and I should find that I'm looking for 4 different zeros here on this interval. This graph is 0 to 2 pi. So what this means is I'm multiplying two numbers, and that each one of them can be 0. So when I look at those two situations, I want to find out when cosine x is 0 or when cosine x is equal to half. If either of these two situations are true, then this equation, this one, and therefore this one will be satisfied. Well, I know when cosine x is equal to 0. That's at pi over 2 and 3 pi over 2. I also know when cosine x is equal to a half. That's pi over 3 and 5 pi over 3. Okay? So there are my 4 solutions. Okay? The 4 solutions that I get from my graph. Okay? So this one I use a Pythagorean identity. I was able to factor, and I got 2 conditions that I needed to satisfy. Let's do another one. Here I can factor right away. Okay? If I factor this up, 2 sine x minus 1, sine x minus 3, looking at this, if I'm on the interval of 0 to 2 pi, it looks like I'm looking for 2 zeros. Okay? And so again, just like we did in the last problem, I want to set each of these 2 terms equal to 0. So I'm going to get sine of x is equal to a half, or sine of x is equal to 3. If I look over here, again, I know when sine of x is equal to a half. That's going to be at pi over 6 and 5 pi over 6. Again, knowing my unit circle, I need to understand that. Okay? So there are 2 solutions. I already have 2 solutions. I'm looking for 2. What about this one? Sine of x is equal to 3. There's no solution to that. Why is there no solution? You guys should all know that. Because the range of the sine function is negative 1 to 1. There's no value, there's no x value I can plug into sine to get 3 to make this term equal to 0. Okay? Understand that. So there's no solution to this part because sine can never equal 3. Alright? Here's some practice. Okay, this is going to take a lot of practice, fellas. You need to do a lot of equations. You need to do a lot of solving of these. That's why I'm going to break them up into a bunch of videos. Look at the examples. The examples are really good. And again, I would tell you, as you watch these videos on solving trigonometric equations, make sure that you're stopping, you're working through them with me. Do the step and then see if you did it correctly. All right, it's going to take some time. Look at graphs. If you're confused as you're going through some of these examples, graph the function. Look on your calculator. Look on 0 to 2 pi. Find out how many solutions you're supposed to have, and then you can plug back in. All right, there's ways to check whether or not you got the right solution. Okay? Again, email me with any questions, and let's make sure that we get off to a good start on this section. All right? Have a good day, fellas.